Yes, good morning to all. Yesterday we discussed about that speed and velocity, their differentiator, and then what is odometer, what is speedometer. Um, Now today we discussed about that acceleration. What is acceleration? Acceleration means the rate of change of velocity. The rate of change of velocity. It means if that velocity change is going on with respect to time, so that is called as the accelerations. Um, when we drive that vehicle, so we changes that accelerations. So that if we changes the accelerations, that it means velocity is changes. That's why with respect to time, that is called as an acceleration. Okay, accelerations, that formula is that acceleration is equal to change in velocity upon time taken. Change in velocity upon time taken. So acceleration is denoted by small a. Remember it, acceleration is denoted by small a. So we write it change in velocity. So change in velocity means from final to minus to initial velocity. That is, final velocity is denoted by v, and initial velocity is denoted by u. Their difference is, it means the change in velocity with respect to time t. Okay, this is that formula of acceleration. Okay, v, here v is equal to final velocity, u is equal to initial velocity. Initial means starting velocity, and the final velocity v means, and t is equal to time taken. The difference between the initial velocity and final velocity with respect to time is called as an acceleration. This is the formula of acceleration. Okay, that acceleration, when did we taken as acceleration is positive, and when do we take that acceleration is a negative? So yeah, write down the point this, um, the acceleration is taken to be positive if it is in the direction of velocity. So assume this is an object. If we applying that velocity, that in the same direction, that acceleration is also changes. So that time we called as a positive acceleration. That time is called as a positive acceleration. If we apply that velocity in the same direction, acceleration changes, then it is called as a positive acceleration. And then when acceleration is opposite to the direction of velocity, then negative x, then it is said to be negative acceleration, then it is said to be negative acceleration. Okay, so when then the velocity, we are applying velocity here but accelerated backwards, it means that is opposite in direction, so then it is said to be a negative acceleration. Okay, We are applying velocity in the forward direction. The acceleration goes backward, then it is said to be a negative acceleration. Okay. Next, what is a uniform acceleration? Uniform acceleration. The uniform acceleration means when an object covers equal velocity in equal interval of time. In equal interval of time is called as a uniform acceleration. Okay, means when an object covers equal velocity in equal interval of time. Yesterday I told you that is a equal velocity. So this is that's 2 meter per second in a, yeah, 10 meter per second in a 1 minute. So 10 meter per second in a 1 minute, it carries like this, then it is said to be a uniform acceleration. One more point I forget here, very important, the SI unit of acceleration is meter per second. Meter per second. Meter per second. So meter per second we can write here m per s, small letter m per slash, that is small s, that is meter per second square. Second square. Okay, meter per second square is the SI unit of acceleration. Remember this, what is the SI unit of acceleration is meter per second. What is the SI unit of velocity? Meter per second. What is the SI unit of speed? Meter per second. Okay, these are the SI units. Now we go to the topic next, non-uniform acceleration. When do we say that non-uniform accelerations? When an object covered unequal velocity in equal interval of time. Unequal velocity, here equal velocity is covered in uniform acceleration. In non-uniform velocity, unequal velocity is covered in equal interval of time. Okay, here I already told you that is assume that in a 10 meter per second in a 1 minute has the same way 10 meter per second in 1 minute, 10 meter per second 1 minute, like this. Here that velocity goes on changing in different, okay, but in equal interval of time, that is called as a non-uniform acceleration. Next we go to that graphical representation of motion. Graphical representation of motion. So here very important this topic also. So what is a would draw the graph of uniform speed. Uniform speed, if you draw the graph uniform speed, you draw this like this graph in the x-axis, and this one is a y-axis. X-axis, this is we taken as a time taken in seconds. Okay, time taken in seconds denoted by small t. and here y-axis we taken here ask which one, uniform speed. In speed what we taken as here, distance. Distance is denoted by s. Okay, denoted by s, we have taken in y-axis. So how it is formation in uniform speed, the graph is, so that it formation in a straight line. It is formation in a straight line. Okay, remember this point also. And then second, non-uniform speed. Non-uniform speed. Same, that is time taken, written as a small t, and the distance s in y-axis. So how is graph is formed in a non-uniform speed? That is in a curve or in a zigzag manner. Curve or zigzag manner. Zigzag means like this also, their formations, not in a straight line, it is in a curve shape or in a zigzag like this. Okay, in a zigzag manner, or we called as a curve shape. In which graph of type this is a non-uniform speed graph. Next we go to the second, uniform velocity. So this is the uniform speed graph and this is the uniform velocity graph. What we write here, so same, in x-axis we write always time, that is time taken in seconds. In seconds, second is denoted by small s, time is denoted by t. And in y-axis what we write here, displacement. Displacement. Okay, so in uniform velocities also the graph is formation as a straight line. Okay, next, non-uniform velocity. Yesterday I explained that what is a non-uniform velocity, uniform speed and non-uniform speed. Today I representing that graphical representation, okay, of uniform speed and non-uniform speed, and uniform velocity and non-uniform velocity. So in x-axis what we write, that is time in seconds t. In a y-axis we write here displacement. Okay, so how it is formed in a non-uniform velocity, the graph is, here is also formation as a curve shape or in a zigzag manner. Okay, but you remember this, if I ask to draw that graphical representation of non-uniform velocity, you should write here displacement in a y-axis, and in a x-axis what you write, time. In always we are taken in x-axis as a time, but remember this, in y-axis here taken a displacement, in a speed we are taken as a distance. Okay, this is the point. Next is a uniform acceleration. Uniform acceleration. Draw the graph of uniform acceleration. If I ask this again, you draw this. This is a time in seconds, x-axis, and y-axis we are taken as a velocity. Velocity v, that is arrow mark. We again, that in uniform acceleration, again if we draw that graph, it should be in a straight line. It should be in a straight line. Now in non-uniform acceleration, Non-uniform acceleration, time in seconds in a x-axis will show it, and then velocity we show in a y-axis. So again here graph is formation in a curve in shape or in a zigzag manner. Just you remember that if asked non-uniform velocity, then you write here in a y-axis velocity, and time in seconds in a x-axis. Okay, uniform acceleration of ask, you write in a y-axis velocity and an x-axis in time in seconds, and formation in a straight line formation. Okay, and then last point is these are the positives results for negative acceleration. The negative acceleration also we called as a retardation or retardation of acceleration. That is how, that is uniform negative acceleration, yeah, uniform retardation accelerations. If asked the graph, so again you draw the same like this in x-axis, taken time in seconds, and then here also velocity v in a y-axis. If all ask uniform negative acceleration or uniform retardation acceleration, so you draw like this in a straight manner. It goes from that from upwards to downwards. It comes from upwards to downwards. Okay, that is a uniform negative acceleration or uniform retardation acceleration. Next is a non-uniform negative acceleration, or we called as a non-uniform retardation accelerations. Same, the graph is in x-axis time in seconds we have taken, and in y-axis velocity. In these situations also we draw that in a zigzag manner or in a curve shape the formations. Okay, like this curve shape, not in a straight line, you form like this. Okay, curve shape or zigzag manner we called as a. So this is about that graphical representation of motion, that is motion, that is distance, graphical uniform motion, that is, and non-uniform speed, uniform speed, uniform velocity, non-uniform velocity graph, and uniform acceleration, non-uniform acceleration, and then uniform negative acceleration or uniform retardation, or non-uniform negative acceleration or non-uniform negative retardation acceleration. These are the graphical representation we discussed. Tomorrow we discussed about the equations of motion by graphical method, and then circular uniform motion, that is uniform circular motion. Okay, thank you.